So there is a gradient element, although I suggest people don't use it. So this is the ability to define a gradient in QML. This actually becomes a C++ object, which will generate you the pixels. However, most graphics drivers do not have very good support for generating gradients. Worst offenders are things like XRender with like NVIDIA cards, which should be really, really fast. When it turns out they do their gradient rendering in software. So here is an example here where we are creating a gradient color. And we're setting a gradient stop at 0 and 1. And we're using blue and green. And Qt will actually generate this gradient for you, blending the colors. However, it would be much more performant for you if you're on an embedded device and the size of this gradient isn't changing, to have your artist pre-render your PNG and use it. So as opposed to actually doing gradients in code, you could just say use 2 images, and these are roughly equivalent. So there is the concept of the text item. So this is a read-only display hunk of text, and you could set it to just straight text. You can throw new lines in there, and it will wrap it will go onto new lines. There's wrapping modes available, and it will accept, quote, basic HTML, which over the years has gotten larger and larger when it comes to rich text in Qt. So any HTML tags that were valid when using QText documents are valid when using the text item. So you can do ordered lists, unordered lists, little tables. Yes? You don't. You could just start it with bolding. It will also accept the old Qt tag that the old Qt rich text used to use. And it could also use cascading style sheets for the, and this is all documented in Assistant. If you look up the basic HTML that's supported, there is some basic CSS that's supported as well. The text, sorry, I keep hitting something, making booming noises. So the text input is a read and write element that the user can use to edit a single line of text. There's also the text area, which is multi-line of text. It is important to note that this does not look like a standard line edit. In fact, it is simply just the text. If you want to make this look like a line edit, you could wrap it in a rectangle and set a border and a background. But out of the box, it is simply just the text. And part of that reason is you might want your line input to look, well, however you want. And it's up to you to put the correct decorations around it. Because Qt, you can make in QML, you can make your own components very easily. You could just basically take that specialized line edit and put it into a separate file. And then it becomes an item that you can use called maybe line edit. So same as the text item, the text input item also has the text property and also has the default signal text changed and a default slot called onTextChange. We'll find out how that works. So QML supports the concept of anchor-based layouts. The idea is that you're going to define relationships between your items. So you could say, I want my one item to be centered in another item. I want my item to fill the size of another item, usually helpful when you want to fill your parent. Or I want to be bound to the left of this item, to the top of this other item. And the standard anchors are left, right, top, bottom, horizontal center, and vertical center. So here's an example here of simple centering of text. Basically, what we would make is an outer rectangle as our top level item, and our text, we say we want our anchors dot center in rectangle 1. So from here on out, regardless of where rectangle 1 moves and where rectangle 1 gets resized to, we're always going to be centered. So another option is to use the anchoring positions here, where you say I want my text to be anchored, my text's right to be anchored to my parent's right. You could also set both a right and a left, or a right and a bottom, and get various combinations thereof. Yes?
We just bring the missing USB stick.
Ah.
There's a UDC case on all the training materials. We have to also everyone.
Okay. So all the code that's being displayed here, all the code that we're going to go over is on these USB sticks. So, and you'll also have these slides as well. So you can take all this information home with you. Yes? The text input? Yeah, there's a text area that's multi-line. So we have this concept of anchoring. And you may notice here that this text is a little ugly, because when we anchor to the right of our parent, our text is smacked right up against the side of our parent, and that's an ugly thing to do. So the fix for this is to use margins, which you can specify along with your anchors. So when I set my right anchor, I might also set my right margin to space my text off of the edge of my parent by a particular amount of pixels. So we can also specify, like here we have setting an anchor left to our parent's left, and then our anchor left margin is actually going to be the equivalent of our parent's width divided by 16. Why 16? Who knows? But since this is a binding, anytime our parent's width changes, that expression is going to be recalculated, and our margin is going to change depending on the width of our parent. Likewise, we're setting a left anchor and a left margin on the image. And we'll also notice that we're using a anchor's vertical center is equivalent to our parent's vertical center. And we've got an interesting one called anchors.baseline. So can anyone guess what anchors.baseline does? So the problem with text is that you have some of the text that actually gets drawn underneath, like the G's. So for text, there's a special anchor called baseline, which is going to align the bottom of the text, not including what goes underneath, so that you can align your text, what artists would say, correctly. So there are some limitations to anchors. You can only anchor to your parent or your siblings. You cannot anchor to items that might be part of your grandparent heritage or your children's children. And anchors basically create dependencies, so that you have your parent is going to be bound using its child, and your child's bound using the parent, and then the parent is bound via some other objects. Sometimes you can end up with a circular dependency that can't be solved. Yes? What? Yes, siblings and parents are the only available anchors. And you can write yourself circular dependencies. You will be yelled at on the application output in Creator or on the command line in Linux, saying that you have a circular dependency, and it will tell you the lines at which define circular dependency. So you can fix one of them or both of them. Also, there is another major difference between the way Qt widgets work and the way QML items work. In Qt layouts, the layouts specify the constraints, and there are constraints that are built into the items, such as size hints, minimum sizes, and size policies. In QML, the items themselves are the constraints. So when working with anchors, you might find out that if you smack 3 items together and say I want one anchored below the other, you might end up with a situation where all of your items get sizes of 0. And the reason for this is that you need some items in your layout to have static constrained sizes. So you might have an item at the top that's 100 pixels, and then an item underneath that that's bound to the bottom of this item and the bottom of the page. Now that lower one will resize and the top one won't. If you told those 2 anchors without the size constraint just to bind and bind, it's not going to evenly distribute the space between the items. It does not work like Qt layouts. So keep that in mind when you're designing your dialogues, that there's going to be certain things that you need constraints on, such as the size of the buttons at the bottom of your screen. And define your constraints for things that don't resize, and then leave open, basically, you just want to just set anchors without widths and heights on things you want to resize. Oh. Sorry, my notes went to the bottom. So when using anchors, like I said, for most things in QML, most of your items are going to have IDs. You're going to use these IDs to set your anchors. And if you are going to want your items to resize with the screen, you simply leave their constraints open and constrain other things within that same anchoring order. So there's actually a lab that is designed to go ahead and to create this basic layout using 3 rectangles and some spacing in between them. There's n number of ways to actually solve this particular problem. You could set their coordinates by dead reckoning. You could even have that dead reckoning be dynamic, because you could set the width of the objects to be parents' width divided by 3 minus your margin spacing. So you could use binding to get these to lay out dynamically. You could also use anchors to get this to lay out dynamically, because we just anchor the left, the blue rectangle to the its left to the parent's left, and anchor all the way down using margins to space them out. Probably the most useful. And when creating gradients, there's the option of actually creating gradient objects or using images. And the lab for this section is basically to go ahead and actually just create some items that look kind of like buttons. Right now don't do anything, but the idea is that you're going to have an icon and some text inside of a rectangle, inside of an outer rectangle that has a gradient. So let's go ahead quickly and look at the code. And we'll notice that the code is relatively short and made up mostly of the layout anchoring, where our background is going to be simply an image. You'll notice that this image has no width and height or anchors specified on it. So what's interesting here is that this just only happens to work because the image happens to be 400 by 200. The objects are actually stacked in a Z order. You can set your Z order by setting the Z property. If no Z property is set, then it defaults to the creation order of your items. So here we have an image, and it gets to be the background, really only because it has the right width and height, and it's made first. Everything else will be drawn on top of it. So there are some coincidences in this code. Coincidences usually aren't good to have in your code. And then we make the rectangle, which becomes the button. So for reference here, we have this red button that is going to have image and text in it. And we're setting the colors using RGBA, and we're using anchors here to actually anchor this image inside of the rectangle. So our anchor is to our parent's left, and we're anchored to our parent's vertical center. And we're also scaling the image to 0.4. Also, the text is on the parent's horizontal center, and it is says launch, and it just has a fixed pixel size for its font. And it's pretty much the same thing for the cancel button. So another interesting thing that comes up in this lab is how to do rounded rectangles, or how to make circles at all. It's a really good question. So there is no ellipse or circle item in QML. If you wanted to make a circle, you could make one by creating a rectangle and then setting its radius to 1/2 of its width. And if you have the same width and height, you'll have a circle. If you want just simple rounded corners on your rectangles, you can simply set the radius property, which is here. You set the radius property, and you will get a rounded corner on your rectangle. And this is something that is specific to the rectangle item. The rectangle item also has a border property. So you could actually specify a border width and a border color. So you can make this look more like a button by putting a little highlight around it. Or maybe you only use the borders when you have focus. Yes?
Can you give any recommendations for designing for different screen sizes? Mobile versus a larger mobile versus possibly a bigger desktop?
Yeah.
Is it best to bind all of those to percentages of other parents?
Well, yeah. Well, you remember there's the same problem that came up with widgets and when Qtopia was around in Qt3. And there's certain user interface paradigms that don't make sense on a small screen, but they make great sense on a big screen. Likewise, things that work on phones doesn't make a whole lot of sense on the desktop. So my recommendation for relatively minor changes, like going from a 3-inch screen to a 4-inch screen, or I would simply use anchor layouts and make sure everything resizes correctly and the portions you want to get bigger, get bigger. And you might set some constraints. You might have we'll talk about how to do like a style file where you can just say, okay, all the buttons, we're going to use property bind to say we're going to bind all the button heights to style.height. So you might just have a different style depending on the size of the screen you're working with. But if you're going from desktop size things or tablet size things and phone size things, you might want to consider having separate QML layout files and using some of the basic things that you make yourself. You might make your own buttons, you might make your own this, but having the user interface be different on a 10-inch screen than it is on a 3-inch screen. Because packing in 10 pounds of stuff into the 5-pound bag rarely works out. And the user interfaces generally look rather empty. When you use like an iPhone app on an iPad, you're like, well, where's the, all these buttons are tiny and they don't use any space. So that's my suggestion. Use anchors to go in small increments and use different wrapper files or something for big changes. In the back, yes?
I'm noticing on your code on the bottom for the cancel button, using out channel 0.5.
Yep.
But I'm not seeing the background bleed through the rectangle. Is it, and I just can't tell, or?
Yeah, I think it's because it's a dark button on a dark-ish background.
But see, I'm gradient on the background, I would expect the color of the button to be slightly different from top to bottom, because you have a gradient going underneath it, and it has a identified alpha channel. It's subtle. Like, it could be from the back, I can't tell. It's darker up at the front. Okay.
Yeah. I'm looking at my screen. I can't really tell, but yeah, that alpha channel will be respected. Yes.
You did this demo starting off with the top level rectangle. Could you start off with the image itself
Yes, you could.
and do a scale that image, the side of the screen you're scaling since it wasn't bound to anything?
Yeah, you would actually, I believe you have to set a property on the image to get it to scale, rather than just being static, but you could have it scale with the size of the item. Okay. So we have apparently 5 minutes to go before lunch. Is that correct? Okay. So we are going to, does anybody have any more questions about anything, really, up front?
You said that the Q object works different than the QML object in the screen with clipping and so forth.
Yes.
Is that isolated to the QML implementation? Because we're going to deploy one set of Qt libraries for desktop and QML.
Yeah.
Is that a problem?
No. So the problem of desktop clipping comes from widgets in general. If you use an X11 widget, a real widget, it clips. So historically, widgets have always clipped because that's the default behavior. If they broke that, then a lot of people's applications are just going to stop working. Even in graphics view, which is sort of a scene graph type of object, and in the future, actual Q scene graph, clipping has been turned off for a very long time. So only when you're making elements in QML will this whole parents don't clip thing happen. Much like if you wrote a graphics view program, parents don't clip there either.
So it's just an attribute change with how the object is instantiated,
Yeah.
as opposed to an actual difference in the
Yeah, they don't share, the Qt widgets and the QML items don't share really much of a common base class other than QObject. So it's not so much a configuration of a certain object, it's that they're different. Yeah. And that should isolate you. In the back.
If I were to create a component, say like a dial out of QML,
Yep.
and I would, insert that into a regular standard desktop application. Let's say I put 2 dials or multiple dials.
Yeah.
I pay additional prices each time that I invoke another dial. I mean, do I have another interpreter running? Do I have?
Oh, good question. So in C++ land, when you want to display one of these user interfaces, you make yourself a Q declarative view, much like you would make your Q graphics view. And you give it a source file, which is like your main QML file. And that declarative view has a JavaScript interpreter, it has its own engine, its own optimizations. If you make one of those, and your QML file makes 4 gauges, you're great. If you make 4 declarative views, that's 4 declarative engines. Much different. Any other questions? All right, so I think we're going to break for lunch now. And I'll give everyone fair warning that we're going to have to step on the accelerator a little bit here to get through the material before the end of the day. But part of the goal here is to get you guys as much information on things you want to know, not so much to go through the slides. So as we move forward, as you have been doing, if anything strikes your eye and you want to ask a question, just feel free to raise your hand. But have fun at lunch. Welcome back, ladies and gentlemen. We are going to move on now to user interaction. Basically, we've gotten as far as we have elements on the screen. We can arrange them, move them around. But the user right now cannot click on anything. They can't type in characters. They can't get things to happen on the screen. So we're going to talk about how to allow the user to use touch or the mouse. And we're going to talk about keyboard input, how to allow the user to use a keyboard or a keypad. So is the concept of a mouse area. There's also a gesture area for doing things with like pinch zoom and things. The mouse area is just another item. Unlike Q widgets, where every widget can be manipulated by events like key event and mouse press event and mouse release event, this is abstracted out in QML. So if you want to have an image on the screen that the user can touch and something happens, you need both an image item and a mouse area item. And there's going to be actually some things that you can do by making this distinction that you couldn't do with widgets. And you have two ways of dealing with the mouse area. You can either handle its signals or use its properties in bindings. Like, is the mouse contained in the area? So let's look at a simple solution here where we have a rectangle with some text in it. And when the area is clicked, we want to change the color of the text, which is basically when you press inside the area, we will change the color of the text. Pretty simple. And as I mentioned, there is a lot of automatic things that happen in QML. If you have a property, you get an automatic signal. For every property or signal, you get an automatic signal handler, also known as a slot. Here, it's called OnPressed, on-released. All of the automatic signal handlers are all going to start with on. So if you want to handle when the mouse has been pressed and released, there is on-pressed and on-release handlers. And you can think of these like, when this happens, run this function, where the function part comes after the colon. So here we're changing the parent's color. And our parent is the text item. So text here doesn't need an explicit ID, because you can always use the parent object, which is sort of like a this pointer, except it points to your parent. And we are using anchors here to make the mouse area fill the entire space of the text. This is the most common way to use a mouse area. You just have it fill the area that you want to be clickable. One interesting thing that you can do with mouse areas that was really hard with widgets is you can have the mouse areas be bigger than the object that they can touch. Now, you imagine you have a very small screen real estate and very fat hands. If you have a button, say, in the upper right-hand corner that's 30 pixels by 30 pixels, it looks kind of small. Maybe it's the antenna that shows you Wi-Fi. Maybe you click the antenna and you can switch your Wi-Fi station. Well, what you can do is maybe all that's around it is a bunch of labels. There's nothing that's clickable. So you might make that area that the user can press on much larger than the actual antenna icon. So when the user clicks relatively near the antenna icon, it will launch the Wi-Fi configurator. So that's just something that you can do because they are separated from the objects at which they're manipulating. So here we are just using a mouse area, and we are using on-pressed and on-released. There is also an on-enter. There's an on-clicked. There's a whole bunch of things that you can do with a mouse area.
Quick question on that.
Yep.
Active area being beyond the image area. Is there any specific way to handle collisions?
Z order. Yeah. So generally, that's something you want to do on a case-by-case basis. If you're going to make a generic component, you would have the mouse area just cover the component. but you might expose a property that would be like, your mouse area size, so that the designer, when they're putting together the screen, could simply specify, I want that area to grow into basically negative coordinates. And they get stacked just like every other item.
You have to worry about the whole mouse tracking issue of, that you have to worry about with the standard tool widgets. When you do like the hub, when you do like an on enter or on leave, you have to make sure that the event gets sent into the widget you want to track.
Yeah, the only thing that still comes up is the whole, do I want mouse move events?
Right.
Yeah, there's still a property for that. So by default, you only get mouse move events when the button's down. You will still get enter and leave. That had to do with an old X thing, basically. Yeah. But for just to save on cycles, the default is you only get mouse move events when the button's down. There are also, we're going to cover this in the slide, but there's also some other oddities when it comes to the mouse area's default setup. Like by default, the mouse area only responds to left click. You have to specify a property setting to accept the right click. There's also a press and hold option that's also different from the desktop. So if the user touches and holds for more than a threshold period of time, then you get on press and hold rather than on pressed. So as I mentioned, you need to set the accepted buttons property if you want to handle anything other than the left button. So when it comes to hovering, you want to make properties change when the mouse enters and leaves. In C++, you would have had to implement the enter event and leave event and set WA hover and all these properties. In QML, it becomes super easy because there's a property on the mouse area called contains mouse. And you can actually use this in a binding statement. So this is an example here of this rectangle's color of an if statement that is inside of a property binding. And as I mentioned before, anytime a variable changes in a binding, QML is smart enough to rerun all expressions that use that variable. So here, every time contains mouse changes, that expression is going to be rerun, and the color may or may not change.
What's the hover enabled in that practice?
Yes. So generally, when you use this, you want to have mouse area given an ID so you can reference its properties. As mentioned before, a lot of times you're going to be giving almost all of your items IDs. So this is actually a shorthand for an if statement. This is valid in JavaScript, also valid syntax and things like C++. This could actually be an actual multi-line if statement if you wrap the whole expression in brackets. So you can actually do some pretty complicated things in your property binding logic. And do note that everything that happens after that colon is in JavaScript. So if you plan on running something complicated over and over and over again, you're going to want to optimize that. Yes? Yeah. No, because the QML is not smart enough to go fishing in the JavaScript functions for all the variable names. So if you had that function, lined up to, some function, it wouldn't be the same. Yeah. So the key points to note is that there's the hover enabled, there's the signals that you can handle, and the properties that you can handle. And if you're wondering why you're not getting right mouse clicks, it's because you haven't configured accept buttons correctly. By default, it only does the left button. Mouse handling is pretty simple. Anybody have any questions on the mouse area? All right. So it's a good question. So we have these signals, and you can actually make your own custom signals in QML. We'll see that later. but we're seeing that we have signals on objects and we have properties on objects. They both will asynchronously run your code or rerun the code. The question is, which do you use? Should you be handling signals or you should be binding to properties? And the answer to that is wherever you can use properties, it's going to yield shorter code. If you're going to handle the signals yourself and do all the property changes yourself in little functions, you're going to end up writing more code. There's some things, though, that you can only handle in signals. So, and of course, favor, as much as you can, simple assignments than calling massive functions. So keyboard inputs is much different than it is in the desktop widgets. And once you get used to it, it's actually very easy to use. So there's two elements that accept keyboard input by default. This is the text input and the text edit. Although any element, if given focus, can handle key clicks and do whatever you want on them. Also, every item has the ability to establish its navigation behavior. When an item is in focus, that item decides when the left button's hit or the tab button's hit, who gets focused next. So here's an example here of two fields, and one of them has focus and one of them does not. In fact, we're probably setting a property to change the color when we're not in focus. And in your application, just like in regular widgets, you can only have, at any given time, one item be in focus. And by default, normally your application will predetermine one of the items to start out in focus. Yes?
Does text input have trigger something that allows you to have the blank text until the user enters in it? You know, like enter text here, they click on it, that goes away, they type, or you have to handle that yourself?
You would have to handle that yourself. So here's an example. Basically what we have is we have got a simple layout, rectangle, two text inputs, but we'll see that we're using the focus property when we're setting the color. So anytime focus changes, our color is going to change. And we'll notice that on one of the elements, we have set focus to true. So when this application starts up, that one item is going to start with focus, and it would have to be moved via clicking or keyboard events to move the focus. That is very similar to the concept in the desktop widgets. And by default, text areas have click to focus, so do things like lists. So when it comes to navigation, in C++, it was always very hairy to set your tab order. And in QML, it's pretty straightforward. Each item determines via this key navigation attached property. It has tab, back tab, left, right, up, and down. That you can say, well, okay, when the user hits tab, then we're going to navigate to the address field. And we'll notice on the address field when the user hits back tab or shift tab that we're going to send the focus on to the name field. So if you set tab and back tab on every particular widget pointing to who is next and back, you basically get a linked list for your tab ordering.
You add keys to the key navigation? Like you said, tab, back tab, up, down, left, right. How about enter?
Good question. That's something I haven't tried. But we can look it up. No, left down, up right, tab, and back tab. You could, however, in your in the next section we talk about was just generic key handling. You could explicitly set focus and move it around. So just here is another example of using the focus property to change color and having our key navigation left and right set. So when the user hits the left button, it'll move back to the left rectangle. They hit the right button, it moves to the right rectangle. Now normally anywhere where you set a forward, you should probably also set a backward navigation as well. Yes? Yes. So, and also at any time in your JavaScript, like you could have a function like onClicked or a function on something, actually take an item and set focus to true, and basically steal the focus from whoever got it via key navigation and assign it to some other item. Yeah. You could be, not really, because it's, I believe the right element wants to be bound to one item. However, what you can do is, rather than setting all of those properties, you can do things with that focus property and use that and salt that around your item to say, well, when I'm in focus, I have the following set of configuration, as opposed to when I'm not in focus. And any item can have focus. So you could just, they don't change the look at all. You have to code that in yourself if you want to do rectangle to look different. But any item can take focus and handle key events. And those key events also bubble up from parent to child all the way up. So if you want to have a master keyboard handle, the handle, say, volume up and down, regardless of, if the child that's in focus doesn't handle the event and say, the keyboard event has been accepted, just like in C++ queues. It will bubble up to its parent. If it doesn't accept it, bubble up, till it gets to the very top level and possibly gets thrown away. So there are some tricks that you can play so that, maybe you're making FM radio. So anytime you hit the volume up and down, that bubbles to the top. But if you hit the keyboard up and down, maybe when you're in the station selection list, it moves the selection up and down and stuff like that. So basically you have mouse areas and you have the key navigation. We'll talk in the next section. Okay. We'll talk in the next section about raw keyboard input, where I just want to handle any character. I just want to know that the A key went down, that the Enter key went down, that F1 was pressed. But we've figured out how to receive mouse clicks. We've talked about the text input and the text edit and keyboard navigation, which makes it a pretty straightforward way to do your tab ordering. So there was a lab that's generally scheduled for this course. I'll show you the solution like the last lab. But the idea is we're basically just going to use keyboard and click navigation to change the colors of 4 rectangles. And if we look at run the solution, we have 4 rectangles. We can click on one, and we're basically moving, whoever is in focus becomes red. And we can use the keyboard left and right, keyboard up and down, or clicking. And basically, we're using rectangles, and we have a mouse area filling the rectangle. And when we are clicked, we set our own focus to true. We're basically going to steal focus from whoever has it. And we implement the key navigation to say that when right has been hit, we go to the green square. When down's been hit, we go to the silver square. And it's basically the same type of thing over and over again. Now, since the rectangle is much like a generic item, it doesn't have the concept of like a focus halo or a dotted line. You have to specify what the changes are going to be using this focus property and using it in expressions. But the language is it's designed to be very straightforward. If there's keyboard navigation going on, generally a designer or a programmer can go directly to the item and see in basically the linked list what's the previous and what's the next.
Is there such a thing as like the grid layout on PC or something like this, where you can say, here is this working, so this week you're looking for X, Y, pray and hope that you want something.
Yeah, there are things called arranger items. They are not layouts. However, they will put things into grids, rows, and columns for you. They will not generally resize items for you. And there's also a really cool thing we'll talk about in a couple of sections called a repeater. So we could actually have it, even though these are slightly different, we could actually say I want a grid of 25 squares, and I want them to be a repeater of rectangles. And then that code will, in 5 lines, will bang out 25 rectangles. That could also be linked into a data model. So it will make one item for each one of the model items, and you can actually access data from the model. Sort of like making like a static list without having a list view. Okay. So raw keyboard input is handled by an attached property called keys. And keys has OnPressed, OnReleased, OnClicked. It also has things like OnAPressed, OnEnterPressed, OnEnterReleased. And those are all just conveniences for you to cut down the amount of gigantic if statements that you need to have. To get the keys delivered to your item, you need to be in focus. That's the same way it works on desktop queues. If you're not in focus, you don't get the keyboard. However, if your item does have focus and specifically wants to send its keys to somebody who's not its parent, you can use keys forward to. And you can actually forward that keystroke to one or many other objects. So here is an example here where we are making a rocket ship. And we have keys on left pressed and on right pressed. These are the very specific signal handlers. There's also a really generic one called on pressed, where you will have to use the key parameter that comes in to switch out, basically a switch statement to figure out what key you want to run. So here we just want left and right, and that's easy. We set our rotation to be a basically a mathematical formula to increment or decrement us 10 degrees. Yes?
Will you be addressing the difference between keys on left press and keys on press?
The difference? Well,
The component doesn't pass up left press. On press and on left press, even if you say if the key is left, are different. They don't pass the keystroke the same.
yeah, I haven't run into that, but that's something I can help you with. There might be a different, like, does it mean it doesn't move it up to its parent?
It doesn't pass it up. If the key is on press, it doesn't pass up on it.
Okay, that might be a difference in the default of the event accepted. But we can look into that. I haven't noticed that. So here we're using the specific ones, and we're incrementing or decrementing our rotation by 10 degrees. And of course, to get these keys at all, we are focus true, or somebody has to set our focus via code. As opposed to this same code using the keys on pressed signal handler is a lot more complicated. If you want to do multi-line JavaScript, you need to have the curly braces, and then you can do, well, whatever you want. So here we're basically checking the event.key for left and right. It is also here where you could say like accepted equals false and send the keystroke upwards. Focus scope. All right. Focus scope really ought to have more than half a slide. Focus scope is very important. I wish I had a whiteboard. So imagine the fact that you have a couple of sibling elements here, and one's an image and one is something really complicated. Inside of it is actually a number of different items, but all we can say here is image focus equals true, for the rocket ship maybe. But when the rocket ship gets focus, it itself doesn't want focus. It wants to pass focus onto one of its children, maybe as some like sort of sub-focus state. To do that, you need to have that item be a focus scope, which is going to delegate its own focus onto one of its children. So when writing code and you want to have keyboard navigation really work, at the very first item, your top level item in most of your files should really be focus scope. And in every file, you should have one element that says focus equals focus true. And if you do that, then when somebody instantiates one of your complicated items and says, you know, rocket ship focus true, the Qt focus system in QML is going to be smart enough to say, oh, it's not really this item, it's this child that has focus equals true down below somewhere, and that's really going to get the focus. And it also has memory. So when you exit focus to say from image to text item, this may be a sibling, and then go back to the image, it's going to be the focus that was at last left. I don't know if that really comes across right. Yeah. All right, let's go into I didn't build examples. All right, so here's a decent visual example here. Imagine that the top area is an item onto its own, and it has 5 Qt logos in it, and they can be in focus. And then we have 3 lists down below. Those lists are in an item, and each list has multiple items in it. So the question here is what happens when we say move focus from list element 1 to list element 1 in the third list and hit the up arrow. The up arrow is going to move focus to the top area. And the top area's last focus item was the third one. It needs to place the focus into the third one again to go back to what the user had. But in reality, in the top level QML file, there's only 2 elements. There's the header portion and the lower portion. So there's a header and a body, let's say. And that's all the focus you have. So you say, initially, I just want to have the header in focus. But that doesn't really mean the header's in focus. It means one of the Qt logos is in focus. And that's what focus scope does. So when I tell the header to be in focus, it actually delegates that to one of its children. Yeah, and this. But the key thing to note, you'll pick it up once you start using it, is that for keyboard focus, generally you want all of your QML files to start with a focus scope. and inside of that file have one element that's focus true.